In this section, I'm going to be talking about box plots. If you recall in the last section, we were talking about standard deviation and variance. Well, in this section, we'll be talking about the minimum, maximum, and range of a dataset, which can also describe the spread of the dataset. Now, when we're talking about the minimum of a dataset, well, it's the smallest value in that dataset. Likewise, when we're talking about the maximum of a dataset, it is the largest value of that dataset. And last but not least, when we're talking about the range of a dataset, it is the difference between the maximum and minimum of the dataset. In pandas, the dataframe.min or .max function are used to find the minimum and maximum. Let's delve into the dataset. We're going to be taking a look at World Happiness Report 2021.csv file. We used that same file in the previous sections. Now first, we're going to import the pandas module, load the dataset into scores data frame. And over here, we're going to print the first few lines of data and determine how many records there are. So I'm going to go ahead and clear my kernel. And I'm going to run it again. And as you can see here, we have the country name, regional indicator, ladder score, generosity, perception of corruption. So all the columns are displayed. And we can see over here number of countries that were used to determine the World Happiness Report. Now let's determine the minimum for the columns in the dataset. So I'm going to type print scores dot minimum. There we go. Now we're able to find the min value for all the columns. Now if I wanted to find the min value for one of the columns, for example, healthy life expectancy, then I will invoke scores, take a look at the healthy life expectancy column, determine the minimum, run it. 48.5 is the life expectancy, years. And as you can see here, it matches this value. That is fantastic. Now we were able to find the lowest life expectancy in our data set. Now, just like the min function, if we wanted to find the maximum, well, instead of using the min function, type max. And you can see here, we have a minimum value in our data set when it comes to life expectancy of 48 years, 48.5 years, and the maximum of about 77 years or so. When we're talking about the range, well, the range is determined by subtracting the minimum from the maximum. So I'm going to type scores, score range, equals scores. And I'm going to be doing some copying here to make it a little bit easier. And instead of max, minimum. And as you can see here, the range is 28.5 years between the minimum and the maximum. Now, when we're talking about percentiles, well, we're mostly referencing 3 percentiles that are particularly important. The first quartile, which is typically the 25th percentile, and typically the first quartile is the median of the lower half of the data. The other percentile is a third quartile, is a 75th percentile. 3/4 of the data fall at or below the third quartile. Now the third quartile is the median of the upper half of the data. Last but not least, because half of the data fall at or below the median is also the 50th percentile of that data set. Now, collectively, the minimum and maximum, first quartile, median, third quartile, form a set of descriptive statistics called the 5-number summary. Again, the minimum, the maximum, the first quartile, median, third quartile form a set of descriptive statistics called the 5-number summary. How can we create a 5-number summary? Easy. All we have to type is print scores dot describe to generate the 5-number summary. Great. That's fantastic. So just to make it a little bit easier, I'm just going to say scores.describe to generate the 5-number summary for our entire data set. As you can see here, you have the minimum, 25th percentile, 50th percentile, 75th percentile, the max, to generate our 5-number summary. This is fantastic. As you can see, we can generate the summary in a matter of seconds. And of course, if we wanted to hone in and take a look at a specific column, we can do so by typing the following. And as you can see, these numbers match the values that we determined earlier, whereby the minimum was about 48.5 years, the maximum for life expectancy was 77 years, and the median life expectancy is 66 years. This table is fantastic, but a lot of times it's a little hard to digest, so that's where box plots come into play. Now, a box plot, it's a data visualization that uses a box and several lines to depict the distribution of data in a data set. Now, a box spans the middle, 50% of the data, with the first quartile as the lower boundary of the box, and the third quartile as the upper boundary of the box. The median is shown as a line inside the box. As you can see here, you have the first quartile, Q1, third quartile, Q3, median, which is the 50th percentile, and also denoted by a line inside the box. There are two lines, known as whiskers, that extend from the lower boundary of the box to the minimum and from the upper boundary of the box to the maximum. Again, from the lower boundary of the box to the minimum and the upper boundary of the box to the maximum. These are called whiskers. The whiskers typically represent the lower and upper 25% of the data. One last item, we have this thing called outliers over here. One way to detect these outliers using a box plot is to determine how far each data element is from either first quartile or the third quartile. The interquartile range of a dataset is the difference between Q3 and Q1, or the length of the box in a box plot. A data value greater than Q3 plus 1.5 times IQR or less than, over here, Q1 minus 1.5 times IQR is considered as an outlier. As you can see here, Q3 plus 1.5 times IQR or Q1 minus 1.5 times IQR. It is not included in either whisker and represented in the plot as a marker such as a open circle, triangle, or even a diamond sometimes, or a closed circle. Now let's try to plot some box plots for our World Happiness Report. So I went over here and generated some code to plot box plots via Seaborn. So right off the bat, I'm loading the necessary libraries, and I'm going to go ahead and plot a box plot. But in this case, I'm going to be taking a look at regional indicator, which is going to be part of my y-axis, and healthy life expectancy being part of my x-axis. Try to show it. Right off the bat, as you can see from our data set, we're able to view the box plots per region when it comes to the life expectancy. When we look at Western Europe and North America, you can see the box plots over here. And right off the bat, you can see the minimum, maximum are above 70 years of age. Now, when we take a look at the median life expectancy, or even the first or even the third quartile of our data for sub-Saharan Africa, the life expectancy is lower than 60. We do have some outliers, but it is substantially lower than regions such as Europe, North America, or East Asia. The sky is the limit when it comes to box plots, but as you can see here, provide tremendous amount of value, enabling us to visualize the data. This concludes the section on box plots. In this section, I'm going to be talking about histograms. But before I do, I'm going to be talking about frequency distribution. Simply put, a frequency distribution is a table that displays how an outcome occurs for a sample. To construct one, the data set is divided into mutually exclusive classes. Now, when we're talking about classes, a class is either a value of a categorical variable or an interval of a continuous variable. Now, when we're talking about frequency, we're not talking 1 divided by time, but the frequency of a class is typically referring to the number of events or values that fall under each class. On the flip side, a histogram depicts data values by splitting a continuous variable into a number of class intervals, each known as a bin. The simplest, most common type of histogram has bins of equal sizes. Before I jump into histograms, I was just going to show you real quick what a frequency table typically looks like. This is an example from Wikipedia where the frequency of each response to a survey question is depicted. We've done many surveys, and as you can see, this table shows degree of agreement and a number. In this case, strongly agree or strongly disagree, and the column on the right is the frequency. Now going back to histograms, I'm going to be pulling my data from this website, kaggle.com, Heart Attack Analysis Prediction Dataset. This dataset is for heart attack classification, and what I'm going to be doing, I'm going to be downloading the following file and using it for my example. First things first, let's import a few modules. Now I'm going to read the CSV file and load it into a data frame. Next, I'm going to print the length of that data frame. And last, I would like to take a quick look at my data set. Let's do a quick check and run. Perfect. So we have 303 number of records. We have a few columns, age, sex, CP. Let's see here. CP, chest pain, CA, number of major vessels, resting blood pressure, cholesterol, fasting blood pressure, resting electrocardiographic results, maximum heart rate achieved, and target. 0 equals less chance of a heart attack, 1 more chance of a heart attack. All right, let's draw a histogram. But before I do, I am going to define bins as int round gf to the power of a half the root 0. Now what is all this over here? Oh, made a quick mistake here. Length of df. Let's see right here. Perfect. Well, kind of just simplify it a little bit more so it doesn't look too complicated. Perfect. So really quick here. So what did I just do? Bin sizes when it comes to histograms. A key goal of a histogram is to estimate the probability density function of the continuous variable on the x-axis. The goal is to fit it with a smooth curve over the most rectangles when minimizing the white space under that curve. Now, when we create a histogram, multiple bin sizes should be attempted to determine the best distribution of the data. We want it to look good. So as a rule of thumb, it is to start with a bin size so that the number of bins is roughly equal to the square root of the number of values. Hence my formula. All right, so now let's start plotting a histogram. So I'm going to paste over here some code and I'm going to run it. Here we go. We can see on the x-axis of the histogram is our age and on the y-axis the frequency. So we were able to split our variable into bins and we can see here the data depicted in a histogram. All right, that is awesome. Now let's make this look a little nicer. So I'm going to be using Seaborn. So what I'm going to go ahead and do is paste some code, import the Seaborn module, set the theme, and plot my histogram. Let's see what it looks like now. Ah, nice. So this is very aesthetically pleasing to the eye. But what I've done is I've added a kernel density estimate to smooth the histogram and provide complementary information about the shape of the distribution. So you can see here the shape of the distribution curve and the histogram for my age group that were studied in the dataset. That is awesome. Now, what if I wanted to plot the histograms for all my dataset? Well, I'm going to paste some code here, creating some subplots. I'm going to be using Seaborn to plot these histograms for the entire dataset, and I'm going to run it. And as you can see here, this shows the histograms for the entire dataset. Nice. Now let's go back and focus on this histogram here. Now what if I wanted to delve into the data further and wanted to see, based on that age group, are you more than likely or do you have more of a chance or less of a chance of a heart attack? Now if you recall in our column, we have an output here, which is the hue for the histogram, which would tell us that if there's a value of 0, you'll have a less chance of a heart attack, and 1, more chance of a heart attack. So how can we combine that piece of information in this histogram? So over here, I'm going to go ahead and type SNS, histogram plot, my data set. I'm going to be taking a look at age, my x-axis. My hue is going to be the output. And I would like them stacked. Let me make some quick corrections here. All right, quick check. There we go. Awesome. Now we can see, even better, visualize heart attack occurrences into groups with an associated color. Each bar now is consisting of multiple colors. As you can see here, the orange represents chance of having a heart attack, and the other group, the blue, is the group of the participants that have less chance of a heart attack. Gonna add my kernel density estimate. Here we go. Great. This concludes our section on histogram. Just to summarize, able to not only plot histograms, but add KDE density lines to show the density of our data, which complements the histogram well.